My dear students, welcome back to our channel. Students, in this video I am explaining Bachelor of Education, first semester. Subject content cum Pedagogy of Mathematics. Important short and long questions and answers. Let's start quick revision. First important short question is: write a brief note on mathematical thinking. Mathematical thinking is the ability to understand, solve, and think logically about numbers and problems. It helps us approach challenges step by step and find solutions. For example, imagine you have 5 apples and you buy 3 more. How many apples do you have now? By using mathematical thinking, you add 5 plus 3 and get 8 apples. This is a simple example of how we use math to solve real-life problems. Mathematical thinking is not just about numbers. It's about understanding patterns, shapes, and making logical connections. For example, if you see a pattern like 2, 4, 6, 8, you can predict the next number is 10. In school, math helps you think critically, make decisions, and solve problems efficiently. It teaches you to break down problems into smaller parts, think logically, and find the best solution. Next important short question is: how the values can be imbibed through teaching mathematics? Values can be taught through mathematics by connecting lessons to real-life situations and encouraging important qualities like honesty, responsibility, and perseverance. For example, when solving math problems, students learn the value of persistence. If a student struggles with a difficult problem but keeps trying, they learn the importance of not giving up. This can be applied to other areas of life. Teaching honesty is another value. When students check their work for mistakes, they learn to be truthful about their answers and not hide errors. Also, math helps develop responsibility. For example, when students work on group projects, they must share the workload and contribute fairly, teaching them to be accountable for their actions. By showing how math connects to life, teachers can inspire students to embrace values like fairness, respect, and discipline, helping them grow into better individuals. Next important short question is: write a note on social pedagogy. Social pedagogy is a way of teaching that focuses on helping students grow not just academically, but also socially and emotionally. It emphasizes building strong relationships and understanding the needs of each student. For example, in a classroom, a teacher who practices social pedagogy doesn't just teach math or science. They also pay attention to how students interact with each other, encourage teamwork, and teach values like respect, empathy, and kindness. Imagine a teacher asking students to work together on a group project. This helps them develop communication skills and learn to respect different opinions. The teacher also makes sure to support students who may feel left out or have personal challenges. Social pedagogy aims to create a safe and supportive environment where students feel valued and can grow as individuals, both inside and outside the classroom. It helps develop responsible, caring, and confident individuals. Next important short question is: write the challenges of secondary stage learners. Secondary stage learners, students in classes 9 to 12, face several challenges as they grow and learn. 1. Academic pressure. The pressure to perform well in exams can be overwhelming. For example, students often feel stressed about board exams, fearing that bad grades might affect their future. 2. Time management. Balancing schoolwork, extracurricular activities, and personal life can be tough. A student might struggle to manage study time along with hobbies, leading to stress and burnout. 3. Peer pressure. Teenagers may face pressure from friends to act or behave a certain way. For instance, they might be pushed to skip studies for fun or follow trends that aren't helpful for their growth. 4. Career uncertainty. At this stage, students often feel unsure about their career path. They might be confused about whether to choose science, commerce, or arts. These challenges require guidance and support from teachers, parents, and counselors to help students stay focused, make informed choices, and manage their emotions. Next important short question is: what is pedagogical knowledge? Pedagogical knowledge refers to the understanding of how to teach effectively. It involves knowing different teaching methods, techniques, and strategies that help students learn better. For example, a teacher who understands pedagogical knowledge will use different approaches based on the needs of the students. If the class is struggling with a topic, the teacher might explain it using simple examples or visuals. If students learn better by doing, the teacher may organize hands-on activities. Pedagogical knowledge also involves understanding how students think and learn. For instance, some students might learn faster by listening, while others may learn better by doing or seeing. A good teacher uses this knowledge to make lessons engaging and effective for everyone. In short, pedagogical knowledge is about how to teach in ways that help students understand and learn well, making lessons interesting and meaningful. Next important short question is: write about the aims of teaching mathematics. The aims of teaching mathematics are to help students understand and apply mathematical concepts in real life. Some key aims include: 1. Developing problem-solving skills. Mathematics teaches students how to solve problems logically. For example, when calculating the total cost of items while shopping, students learn how to apply addition and multiplication. 2. Building critical thinking. It helps students think critically and make decisions. For example, when working with patterns, students learn to predict and analyze outcomes. 3. Enhancing analytical skills. Mathematics encourages students to break down complex problems into smaller, manageable parts. For instance, solving a complex algebraic equation teaches students how to approach difficult problems step by step. 4. Practical application. Math teaches students how to use concepts in daily life. For example, understanding geometry helps in measuring areas and distances, which can be useful in construction or designing things. Overall, the aim is to make students confident in using math to solve real-world problems. Next important short question is: how do you appraise critical pedagogy? Critical pedagogy is an approach to teaching that encourages students to think critically about society, power, and justice. It focuses on helping students understand and challenge the world around them, rather than just passively learning facts. For example, in a history lesson, instead of only memorizing dates and events, a teacher using critical pedagogy might ask students to think about how certain events affected different groups of people. This helps students understand different perspectives and develop a sense of fairness and equality. Critical pedagogy also encourages students to question the status quo and think about how they can create positive change. It empowers them to not just accept things as they are, but to analyze and challenge unfair systems or practices. Overall, it promotes active learning, social awareness, and helps students become more responsible, thoughtful, and engaged citizens. It is about making learning meaningful and connected to real-life issues. Next important short question is: what are the steps of project method? The project method is a teaching approach where students learn by working on a real-world project. It helps them develop practical skills, teamwork, and problem-solving abilities. The steps of the project method include 1. Selection of the project. The teacher and students choose a topic for the project. For example, students might choose to create a small garden in their school. 2. Planning. Students plan how to complete the project, dividing tasks among themselves. They decide what materials are needed and set deadlines. 3. Research and preparation. Students gather information and materials needed for the project. For the garden, they might research which plants grow best in their area. 4. Execution. Students carry out the project, like planting the seeds, maintaining the garden, and observing its growth. 5. Presentation. At the end, students present the project results, explaining what they learned. 6. Evaluation. The teacher and students discuss the project, what worked well, and what can be improved. This method makes learning more interactive and meaningful. Next, important long questions. First important long question is: how do you promote mathematization in students? Explain with suitable examples. Promoting mathematization in students means helping them understand how math can be used to make sense of the world around them. It involves encouraging students to think mathematically, solve problems, and apply mathematical concepts to everyday life. Here are a few ways to promote mathematization with suitable examples. 1. Connect math to real-life situations. One of the best ways to promote mathematization is by showing how math is used in daily life. For example, when students go shopping, ask them to calculate the total price of multiple items or figure out discounts. This will help them see how addition, subtraction, and percentage calculations are used in real-life decisions. Example: ask students to calculate how much money they would save if they buy an item with a 20% discount. This promotes practical use of percentage calculation. 2. Encourage problem solving. Provide students with real-world problems that they can solve using math. This helps them develop critical thinking skills and learn to use math as a tool to solve challenges. For instance, you can give students a task to design a small park or garden and calculate the area, perimeter, and the amount of fencing needed. Example: if students are learning geometry, ask them to calculate the area of their classroom floor or the school playground. This makes math feel relevant and interesting. 3. Use hands-on activities. Using hands-on activities helps students engage with math more deeply. Activities like measuring the height of a building using shadows, trigonometry, building shapes using clay, geometry, or measuring ingredients for cooking, fractions and ratios, encourage students to apply math concepts practically. Example: ask students to measure the dimensions of their school's playground and calculate how much material would be needed to cover it. This combines measurement with real-life applications. 4. Encourage group work and discussions. Working in groups allows students to discuss different approaches to solving a problem, which enhances their understanding and promotes critical thinking. For example, in a group project, students can solve math problems related to budgeting, like planning a small event or creating a school fundraiser budget. Example: divide students into groups and ask them to plan a field trip with a budget. Each group will calculate transportation costs, food expenses, and other needs using math to organize the plan. 5. Use technology and visual aids. Technology and visual aids like graphs, charts, and interactive software can help students understand abstract concepts better. For example, Students can use graphing software to plot the relationship between different variables or use online games to practice multiplication and division. Example: use graphing tools to show how temperature changes throughout the day or to illustrate the relationship between distance, speed, and time. This brings the math to life. By connecting math to the real world, using hands-on activities, and encouraging problem solving, students will start to think mathematically and use these skills in various situations. Next important long question is: mention the contributions of Aryabhatta for the development of mathematics. Aryabhatta was an ancient Indian mathematician and astronomer who made significant contributions to mathematics and science. His work laid the foundation for many mathematical concepts still used today. Here are some key contributions of Aryabhatta. 1. Place-value system and zero. Aryabhatta is often credited with developing the concept of the place-value system, which is crucial for understanding numbers. Though the full system of zero was developed later, Aryabhatta's work on numbers and their position laid the groundwork for it. Example: in modern math, the number 205 means 205, where each digit's position determines its value. Aryabhatta's work on numbers helped us understand this concept clearly. 2. Approximation of pi. Aryabhatta gave an approximation of the value of pi, the ratio of the circumference of a circle to its diameter. He approximated pi as 3.1416, which is very close to its actual value, 3.14159. This was a significant contribution to geometry and trigonometry. Example: in a circle with a diameter of 1, Aryabhatta calculated the circumference as 3.1416. This approximation is still used in many calculations today. 3. Trigonometry and sine function. Aryabhatta introduced the concept of sine, called jya in Sanskrit, and used it in his astronomical work. He created a table of signs for various angels, which became the basis for trigonometry in later centuries. Example: in trigonometry, the sine of an angle is a ratio of the opposite side to the hypotenuse in a right triangle. Aryabhatta's work made it easier for mathematicians to work with angles and circles. 4. Algebra. Aryabhatta also made contributions to algebra, including solving quadratic equations. He used methods that were similar to the ones we use today. Example: he solved equations like x2 is equal to 100, where x is equal to 10, and helped develop methods for finding unknown quantities, which is the foundation of algebra. 5. Concept of time and the Earth's rotation. Aryabhatta correctly stated that the Earth rotates on its axis, which causes day and night. He also provided a method to calculate the length of a year, which was very accurate for his time. Example: Aryabhatta's estimate of the length of a year was 365.358 days, which is very close to the actual value of 365.25 days. In conclusion, Aryabhatta's contributions in mathematics and astronomy influenced later Indian and world scholars. His work on pi, trigonometry, algebra, and the Earth's rotation continues to be an important part of modern science and mathematics. Next important long question is: define pedagogy. Explain the types of pedagogy in mathematics. Pedagogy refers to the method and practice of teaching. It involves how teachers deliver lessons, interact with students, and help them understand and learn concepts. The goal of pedagogy is not just to pass on knowledge but to engage students, encourage critical thinking, and help them apply what they learn in real-life situations. In mathematics, different types of pedagogy are used to make the subject more engaging and easier to understand. Here are some key types of pedagogy used in teaching mathematics. 1. Traditional pedagogy, teacher-centered approach. In this method, the teacher is the main source of knowledge, and students are expected to listen, take notes, and follow the teacher's instructions. The focus is often on memorizing formulas, solving problems, and preparing for exams. Example: a teacher explains how to solve a quadratic equation step by step on the board, and students practice similar problems individually. 2. Constructivist pedagogy. This approach encourages students to actively build their own understanding of mathematical concepts. Teachers guide students to explore and discover solutions, rather than just giving them the answers. It focuses on critical thinking and problem solving. Example: in a geometry lesson, students might be asked to explore the properties of different shapes by drawing them, measuring their angles, and discussing their findings. This allows students to discover patterns and relationships on their own. 3. Problem-based learning, PBL. In PBL, students are presented with real-world problems and encouraged to solve them using mathematical concepts. The focus is on developing problem-solving skills, teamwork, and applying math in practical situations. Example: students might be given the task of planning a school event and calculating the budget, space, and resources needed. This makes math more relevant and useful in everyday life. 4. Collaborative pedagogy. This approach emphasizes group work and peer learning. Students work together to solve problems, share ideas, and explain concepts to one another, enhancing their understanding. Example: in a group activity, students may work together to solve a complex algebraic problem and discuss different methods of solving it, helping each other understand different techniques. 5. Inquiry-based pedagogy. Inquiry-based learning focuses on asking questions, exploring concepts, and finding solutions through investigation. Students are encouraged to ask questions, conduct experiments, and think critically. Example: in an investigation about patterns in numbers, students might explore sequences like the Fibonacci series, asking questions about how and why the pattern works. By using these different types of pedagogy, teachers can make mathematics more interactive, engaging, and meaningful for students, helping them develop a deeper understanding of the subject. Next important long question is: explain about Lee Shulman's 7 categories of teachers' knowledge. Lee Shulman, an educational researcher, identified 7 important categories of teachers' knowledge that help educators become effective in the classroom. These categories help teachers understand what knowledge they need to teach well. Let's break down each category with examples. 1. Content knowledge, CK. This is the knowledge of the subject being taught. A teacher must understand the concepts, facts, and information related to the subject, whether it's math, science, history, or any other field. Example: a mathematics teacher must know how to solve quadratic equations, understand algebraic rules, and be able to explain these concepts clearly to students. 2. Pedagogical knowledge, PK. Pedagogical knowledge is about understanding how to teach effectively. It involves knowing different teaching methods, strategies, and approaches that work best for students. Example: a teacher might use group work, discussions, or visual aids like charts and diagrams to teach geometry in a way that helps students understand better. 3. Pedagogical content knowledge, PCK. This is a combination of content knowledge and pedagogical knowledge. It is the ability to teach specific content in a way that is easy for students to understand. Teachers must know not just the subject, but also how to explain it clearly. Example, when teaching fractions, a teacher might use visual aids like pie charts or hands-on activities, cutting pieces of a cake, to help students understand the concept of dividing into parts. 4. Curricular knowledge. This involves knowing the curriculum or syllabus and understanding the learning goals for students. It also includes knowing what students have learned before and what they need to learn next. Example, a math teacher must know that students need to understand basic addition and subtraction before moving on to multiplication and division. 5. Knowledge of learners, goal. Teachers must understand their students' abilities, learning styles, needs, and challenges. This helps in adapting lessons to suit individual students. Example, a teacher may recognize that some students learn better with visual aids, while others prefer hands-on activities, so they can plan lessons accordingly. 6. Knowledge of educational context, KEC. This involves understanding the educational environment, including school policies, classroom culture, and resources available. Example, a teacher might adapt their lesson to fit within the time constraints of a school schedule or make use of the technology available in the classroom. 7. Knowledge of educational goals, KEG. This category refers to knowing the broader goals of education, like fostering critical thinking, creativity, or problem-solving skills, and how to align lessons with those goals. Example, a teacher in a history class may focus on helping students not just remember dates and events, but also develop the ability to analyze historical sources and think critically about the past. In summary, Schulman's 7 categories of knowledge emphasize that teaching is not just about knowing the subject, it's about understanding how to teach it effectively, knowing your students, and aligning lessons with educational goals. This holistic understanding helps teachers become more effective in helping students learn. Next important long question is: write about the inductive and deductive approaches in teaching mathematics. In teaching mathematics, 2 common approaches are inductive and deductive reasoning. Both methods are used to help students understand and learn mathematical concepts, but they work in different ways. Let's explore these approaches. 1. Inductive approach. The inductive approach is a student-centered method where students discover mathematical rules or patterns by observing examples. The teacher starts with specific examples and guides students to identify general principles or rules. Example, imagine a teacher teaching students about the pattern in even numbers. The teacher might start by writing a few even numbers on the board: 2, 4, 6, 8, 10. Then, the teacher asks the students, "What do you notice about these numbers?" Students might observe that all the numbers are divisible by 2. From this observation, students can then conclude that even numbers are divisible by 2. In this approach, students are encouraged to observe, identify patterns, and come up with conclusions on their own. This helps them become active learners, engaging with the material in a hands-on way. 2. Deductive approach. The deductive approach is a teacher-centered method where the teacher first explains a general rule or principle, and then students apply it to specific examples. The focus is on starting with known facts or general principles and deriving conclusions from them. Example, when teaching the Pythagorean theorem, the teacher might start by stating the rule and explaining its meaning. Then, the teacher provides examples, like finding the length of the hypotenuse in a right triangle when the lengths of the other 2 sides are known. For instance, if one side is 3 units and the other is 4 units, students will use the formula to calculate the hypotenuse, c is equal to 5. In this approach, the teacher provides the rule first, and students apply it to specific cases. Key differences. Inductive approach focuses on discovering patterns and rules from examples, while deductive approach focuses on applying pre-known rules to specific examples. Inductive reasoning encourages students to think critically and make their own observations, while deductive reasoning helps students understand why a rule works. Both approaches are important in teaching mathematics and can be used together to help students better understand mathematical concepts. Next important long question is: distinguish between Bloom's and Anderson-Krathwohl's taxonomy of learning objectives. Bloom's taxonomy and Anderson and Krathwohl's taxonomy are both frameworks used to classify learning objectives and help educators design effective teaching methods. They are similar in many ways, but they differ in terms of structure, language, and focus. Let's understand the key differences with examples. 1. Bloom's taxonomy, 1956. Bloom's taxonomy, created by Benjamin Bloom, is a framework for categorizing educational goals. It is often used to structure learning objectives in a hierarchical order, moving from simpler to more complex cognitive skills. The levels of Bloom's taxonomy. 1. Knowledge, remembering facts, definitions, or concepts. Example, memorizing multiplication tables. 2. Comprehension, understanding the meaning of information. Example, explaining a mathematical formula in your own words. 3. Application, using knowledge in new situations. Example, solving a word problem using multiplication. 4. Analysis, breaking down information into parts and understanding relationships. Example, analyzing a graph to find trends. 5. Synthesis, combining different pieces of information to create something new. Example, writing a research paper based on collected data. 6. Evaluation, making judgments based on criteria. Example, critiquing a mathematical method for its efficiency. 2. Anderson and Krathwohl's taxonomy, 2001. In 2001, Anderson and Krathwohl revised Bloom's original taxonomy to reflect a more modern understanding of how learning occurs. The major difference is that they use verbs rather than nouns and emphasize the action that students take during learning. The levels of Anderson and Krathwohl's taxonomy. 1. Remember, recalling facts or basic concepts. Example, recalling the Pythagorean theorem. 2. Understand, explaining ideas or concepts. Example, explaining why the Pythagorean theorem works. 3. Apply, using information in new situations. Example, solving a geometry problem using the theorem. 4. Analyze, breaking down information into smaller parts. Example, analyzing the steps in a solution to a problem. 5. Evaluate, making judgments based on criteria. Example, deciding which mathematical approach is most efficient for solving a problem. 6. Create, putting elements together to form a new structure. Example, designing a new mathematical model to solve a real-world problem. Key differences. Focus on action. Anderson and Krathwohl's version uses verbs, example, remember, understand, create, while Bloom used nouns, example, knowledge, comprehension, synthesis. Revised levels. In the revised taxonomy, synthesis is replaced by create, emphasizing the importance of creative thinking in learning. Structure. Bloom's taxonomy was more rigid in hierarchy, while Anderson and Krathwohl's version allows for more flexibility, as learners can engage in higher-order thinking at different stages. In summary, both taxonomies aim to organize learning objectives but differ in their structure, language, and emphasis on the process of learning. Next important long question is: describe the steps of content-cum methodology. Content-cum methodology is an approach to teaching where teachers integrate both the subject content, what to teach, and the teaching methods, how to teach. The idea is to help students understand not only the subject but also how to learn it effectively. This approach emphasizes the connection between the material being taught and the best methods to teach it. Here are the key steps in the content-cum methodology approach. 1. Understanding the content. The first step is for the teacher to thoroughly understand the subject matter. This means knowing the key concepts, facts, and skills that need to be taught. Example: if a teacher is teaching the topic of fractions in mathematics, they need to understand how fractions work, different types of fractions, proper, improper, and how to simplify or add them. 2. Choosing the right teaching methods. Once the content is understood, the teacher must decide on the most suitable teaching methods for delivering that content. This step considers the needs and learning styles of the students. Example: if the class has visual learners, the teacher might use diagrams and charts to explain fractions. If the students are more hands-on, the teacher might use objects like pizza slices or pieces of fruit to demonstrate fractions. 3. Planning the lesson. The teacher plans how to organize the lesson, combining both the content and the methodology. This step ensures that the lesson is structured logically and flows smoothly. Example: the teacher might start with an introduction to fractions, followed by a hands-on activity using objects, then explain more complex fraction problems, and finally give students time to practice on their own. 4. Using interactive and engaging methods. The teacher should engage students in active learning. This could include group work, discussions, or activities where students apply what they are learning in real time. Example: in a lesson on fractions, the teacher might ask students to work in pairs to divide a set of objects into equal parts. This helps them apply the concept of fractions in a fun and interactive way. 5. Assessing student understanding. After teaching, the teacher assesses how well students have understood the content. This can be done through quizzes, discussions, or asking students to solve problems. Example: after a lesson on fractions, the teacher might give students a worksheet with fraction problems to solve. The teacher can then check the answers to understand which students need further support. 6. Reflecting and adjusting the lesson. After teaching the lesson, the teacher reflects on what worked well and what needs improvement. If some students didn't understand, the teacher might adjust future lessons accordingly. Example: if many students struggled with simplifying fractions, the teacher may plan a review lesson or use different methods to explain the concept. Conclusion: the content-cum methodology approach is about combining strong subject knowledge with effective teaching methods. By carefully planning the content and using the right teaching strategies, the teacher helps students learn better and more efficiently. Next important long question is: how do you integrate activity-based learning in teaching mathematics? Explain with one example. Activity-based learning, ABL, is a teaching approach where students learn by engaging in hands-on activities and real-life experiences, rather than just listening to lectures. It helps make learning more interactive, fun, and effective, especially in subjects like mathematics. By using activities, students can apply mathematical concepts to real-world situations, which deepens their understanding. Steps to integrate activity-based learning in teaching mathematics. 1. Select a mathematical concept. Choose a concept that is suitable for activity-based learning. This could be anything from basic arithmetic to geometry or algebra. 2. Design an activity. Plan an activity that allows students to apply the concept in a practical way. The activity should be simple, enjoyable, and related to the lesson. 3. Involve students. Encourage students to actively participate in the activity. This can include group work, discussions, or individual tasks. 4. Reflect and discuss. After the activity, discuss the results and relate them to the mathematical theory. This helps students connect practical experience with theoretical knowledge. Example, teaching fractions through pizza sharing. Let's say the topic is fractions. A fun way to teach fractions is through the example of pizza sharing. 1. Activity setup. Take a large pizza or draw a pizza on the board. Explain that the whole pizza represents a whole. Then, ask students to divide the pizza into equal parts. For example, divide it into 4 slices, 6 slices, or 8 slices. 2. Student involvement. Ask students to imagine that they are sharing the pizza with their friends. Each student can take a portion of the pizza, and you can discuss how much of the pizza each student gets. For example, if there are 8 slices and 4 students, each student gets a quarter of the pizza. 3. Reflection. After the activity, ask students questions like, how much of the pizza did each person get? How did you divide the pizza? Can you write this division as a fraction? This connects the hands-on experience of dividing the pizza with the abstract concept of fractions. Benefits of activity-based learning. Engagement. Students are more engaged because they can see how math applies to real life. Understanding. It helps students grasp concepts better by experiencing them directly. Creativity. Students are encouraged to think creatively and solve problems in different ways. In conclusion, activity-based learning makes mathematics more enjoyable and easier to understand by allowing students to actively participate in the learning process through practical and fun activities. I hope you understand easily each question. All the best, students, for your upcoming exam. For other subject quick revision. Important questions. Previous question papers. And syllabus. Links are available in description. Check out once. Thank you for watching. Like and share this video with your friends.